All right, so this video is going to be more of like a reaction video. I don't even know if reaction video is the correct like category, but go check out Tom Does Tech. He's another YouTuber who does tech content related to Next.js and various other things. But he recently published a video with kind of like an interview question using like system diagrams. So I figured, hey, this is kind of related to the content I just been publishing. So let's just go ahead and try it out. I think the first 2 minutes is him explaining the problem. So I might just let this play a little bit. And then I'm going to try my best to use my approach to solving the problem. I like using AWS for my solutions, so I might do that. And then we're going to kind of watch the rest of his video to see how he did it. Okay, so let's just go ahead and get started.
In this video, I want to take you through an interview question that I think is fairly interesting because when you first see the problem, it seems impossible to solve. But once you know what sort of solutions are available, it suddenly becomes fairly easy. So we've got some criteria here. So we need to generate a report. And we can generate anything from 1,000 to 100,000 reports a day. So the first thing we know is that this thing needs to scale to some serious capacity. And each report can take 10 to 90 seconds to generate. So these could be reports with a lot of data in them.
So I'm going to pause it and just kind of walk you through some of the things that are going through my head. So right at the bat, I would probably use AWS Lambda since it can really, process a lot of things concurrently. And additionally, since this is something that runs daily, you might want to use like AWS CloudWatch for setting up alarms to basically set up a cron job to fire off these events every so often. And then Lambda has a timeout of about 15 minutes. So if a report only takes 10 to 90 seconds, like this is a good scenario of when you could potentially use a serverless approach. I'm also guessing every report would have its like isolated runner. Let's just go ahead and keep going.
And of course, we're not allowed to lose any reports. So a report has to be completed on that schedule.
So again, I'm going to pause it here. So cannot lose any reports. One thing I really like about Lambda, and if you were to hook it into something like SQS, when the Lambda were to throw an exception or fail, for example, let's say that you are just trying to generate too many reports and whatever upstream service or database you're just overloading and you start getting errors, the Lambda will fail, but it'll push that event that it was trying to process back into an SQS queue, right? So basically the queue will keep on trying over and over and over again until it successfully generates the port. So there's a lot of error handling built into SQS and Lambda. So it has a lot of good synergy. And then also there's something called like a dead letter queue, where if something were to fail, you can actually push failed events to a dead letter queue, and then you can further investigate or process why that report is not working. So those are the things that are kind of going through my head. Sorry for pausing it so much.
And we query an external data source. So we might have a data source here that is something like Amazon Athena, or we might have some sort of database as a service. And we've also got some information about the infrastructure here. So our application is horizontally scaled, so that's good. We can receive a kill signal at any point. So we know that our application is probably running on something like a spot instance. And once it receives that kill signal,
so the horizontally scaled I already mentioned, like Lambda can horizontally scale super easily. The kill signal thing is something that's kind of new to me. Off the top of my head, I would be like, okay, well, we could use SNS, which is basically a way to subscribe to a topic. And whenever you send in that kill signal to the SNS topic, we could just tell all the Lambdas that are running to basically stop. And we could also potentially clear out the SQS queue. So any currently processing events would just be basically purged from the queue. And all these reports will stop processing. Easier said than done, but that's kind of the first thing that's come to my head.
It has 45 seconds to shut down. Okay, so we can see a serious problem here. Reports can take up to 90 seconds, but if we receive a kill signal, then we have 45 seconds to shut down. So what happens if we're 10 seconds into generating a report that's going to take 90 seconds and we receive that kill signal? Well, then we might lose the report and we're not allowed to do that. And this is not the only responsibility for this service. It's also doing other tasks. And so this is interesting because it tells us that we need to find a time to generate these reports where this service is at its lowest capacity. So this is generally probably midnight.
So again, these aren't really concerns for what I'm planning because Lambda, like it just runs, right? You don't have to couple it with other services. You can just throw a bunch of events and Lambda will just scale up and process all this load for you. So the one thing I would be concerned about is this one queries an external data source. So we don't know how resilient that external data source is, right? If you just flood it with a bunch of requests and queries, can it handle those requests, or is it going to start throwing errors? Are you going to potentially crash that external data source? So Throttling may be something that comes into play, but again, if you're using Lambda, there's something called, I think it's like provision capacity or reserve capacity. I forget the term, but you can actually put a number to say that, hey, you're only going to be able to process X amount of things at a time from an SQS event so that you don't potentially flood downstream services. So I think I have an idea about that, and needs to distribute load. Let's just kind of play through.
And we need to distribute the load. So we know this is horizontally scaled, and we need to distribute the load of generating these reports across several different instances. So if you want to have a go at trying to solve this problem, now's a good time to pause the video, go draw out an architecture that you think might work, and then come back and watch the rest of the video. And if you're not already, please make sure you hit that subscribe button. It's free, and I very much appreciate your subscription.
Yeah, so let's just go ahead and do that. Go ahead and subscribe to him, like he said. TomDoesTech, that's his YouTube channel name. But let's just try this out. So let's try to figure out a system that can do this. All right, so first off, CloudWatch, right? There's a way to set up cron job events in CloudWatch. And you could basically set up a cron job, I'll just say daily cron job, to trigger off some type of a Lambda, which needs to do some type of batch processing. Okay, let's go back. We need to generate over 100,000 reports a day. So I don't know where these reports come in. Maybe there's like special IDs or something like that. I don't really know where this would come from, but I'm assuming that there's some type of database that you read from to figure out what reports you need to generate. Maybe you have a list of IDs, like I just said. So let's just go ahead and trigger off a Lambda. And that Lambda, when that cron job fires off, I'll just say this will be the I'll call this the report dispatcher. Something like that. I don't know. But I'm assuming that there's some type of database, right? I don't really know. There's not enough information to really perfectly design this. But again, we're just kind of guessing at this. So there's some type of database that has like a list of IDs, maybe. I don't know. And every ID represents like a report that you need to generate. So this thing will fetch from that database, get the list of IDs that it needs to process for that day. And what I would recommend doing is publishing all those to an SQS queue, right? I've done this before at work. SQS is a great way to basically distribute load and process it all concurrently. Okay, so I'm going ahead and just say publish one event per ID. And again, like you're not going to build a perfect solution unless you actually understand all of the edge cases and requirements. So I'm just kind of showing you the first thing that comes to my mind. Maybe this will work, maybe it won't. I'm gonna make this medium. There we go. So like I said, the cool thing about SQS is that as you're publishing events, you can actually have another Lambda set up like this. And go ahead and draw a line there. And this will be the report generator, okay? Now for every event that comes in, I'm assuming there's more data that you have to fetch from, he says, an external data source. Okay, let's just put an icon. This is going to represent like the internet. So there's an external data source. All right, let's go ahead and I'm guessing this is an API. There's not enough information to really know what it is. Maybe it's like a database that they gave you some type of VPC access to or something. I don't know. We'll do this, right? And so actually I'll do the other way around. I'm guessing we want to fetch data. Okay, so we're going to go ahead and draw the arrow like this. So I'll say, let's just go ahead and say one. I also like to label these things. So I'm going to say one trigger daily cron job. Okay, that's going to invoke a Lambda. The Lambda is going to fetch list of reports we need to generate. Okay, and I'll say 3 publish events. So this could be like 100,000 events, right? We just keep on pushing events into the queue. Finally, this thing will consume events. And then finally, when it gets an event, we're going to go ahead and pull in whatever data we need to generate this report. Now, I don't know what a report is. Like, is this like a PDF that we're trying to generate? Is this just a CSV file? I guess it doesn't matter because that's kind of outside the scope of the problem we're trying to solve. But let's take a peek at what else we need to do. So each report can take 10 to 90 seconds, cannot lose any requests. So as far as the losing any requests, let's say there's some data, like you get an ID and the ID just for whatever reason just doesn't work with this external database. or this external API or something, right? So what I would do is I would add another queue here. I'll call this a dead letter queue, And what will happen is if something fails X amount of times, so like, let's just say the limit is 3. So I'll say like try 3 times, okay? If for whatever reason the event fails, by default, SQS and Amazon will just retry the event. So if this thing fails, it'll push the event back into the queue, and then later that'll get picked up again to try at a later point. If this keeps failing, this will actually get pushed into a dead letter queue. So I'll say push into DLQ on failure. Now we could set up some type of system to automatically like retry this dead letter queue and just push all those events back into SQS. But typically if it failed 3 times to like process this event, there's probably something wrong with this event and you have to go manually inspect the data to figure out why does this keep failing, right? So you can't just continuously push it back into the queue, especially if your retries are high. Like if you were to set the default retry level to like 5 or something, then you have more confidence that there's just something wrong with this ID that we got from this list of IDs, right? All right, so that's kind of my cannot lose any reports. There's a paper trail that tells you that, hey, like something is not working. Again, Lambdas can compute up to 15 minutes. So I think we're good in that aspect. Everything else is taken care of, right? Amazon has a lot of cool things that basically just scale up for you with very little effort. The one thing that we need to focus on is can receive a kill signal at any point. So this is the one thing that's kind of new to me. I haven't actually like thought about building this, and I haven't actually built this in any real systems before, but I do know about SNS. So I'll say SNS topic. And what we could potentially do is when we get an event on this topic, well, I guess we need to think about where does a quick kill switch come in? Is that a user that does the kill switch? So I'll just say like user kills the process. Okay? I don't know if it comes in from an external system, but something has to kill the process, right? So I'll say user kills the process, and what happens is that he could potentially have like a CLI command or like a UI where he clicks a button, and that button needs to basically do a couple of things. The first thing I would probably do is make this be another Lambda, right? I love Lambdas. I'll say kill switch. And this kill switch needs to do 2 things. It needs to publish an event to the SNS topic so that every currently running report generator is killed. Okay, so there'll be some code inside of this report generator to basically listen for SNS topic events. And if that event comes in while it's doing its processing, just go ahead and exit the process, throw an error. I don't know. Well, I guess you don't want to throw an error because it'll just keep retrying that thing. So you'd want to actually just gracefully exit when that kill switch comes in. But the second thing you probably want to do is you want to clear out this SQS queue, right? So we want to basically go here. I'm kind of running out of real estate with this crazy diagram, but we're going to want to basically pass in or purge the SQS queue. Okay. And let's go back to the video. Needs to distribute load. Okay, not only responsible for the service. Some of the stuff is built in a way, like it's stated in a way that you have like VMs or you have like Kubernetes or Docker. Again, I chose a serverless approach because I love Lambdas. I think that they're a great way to build systems. And this ultimately is the approach I would probably take. Okay, I think there might be some things that are wrong with this approach, but I think overall, this would probably handle the issues mapped out in this generate reports problem statement. Now, before I finish watching his video, I do want to just take a second to like digest what I just did. Because again, I didn't like plan for this. I just started diagramming and I want to make sure that I didn't miss anything. I'm guessing reports, if reports are PDFs, which I've done on my own work project, you probably want to store in an S3 bucket. So as these reports are finishing, you want to store them in a bucket. So like, I don't even know what number I'm at now. Store reports in bucket. Or if they're CVSs, it doesn't matter because they'll store them. Yeah, I think that's good. So at this point, I'm happy with the solution. Is it the perfect solution? I don't know. You leave a comment. You tell me if I missed something. You tell me if there's something I can do better. or if there's some service I use that I could replace with something else like Lambda, such as like Lambda step functions or something like that. But let's go back and watch the rest of his video because I do want to see his approach. I haven't finished watching his video. I stopped it here, and let's just continue forward. I might not talk that much going forward, but let's see.
Okay, so let's draw out what we know this infrastructure looks like currently. So we have an application layer here, and inside of that application layer, we have a single service that is running several different instances. So we might be running Kubernetes, for example, and then these might be different pods with our application running in each one. So let's say for now, we only have 3 instances of the service running. And then we also know that we have a database. So let's draw that. And I'll just label this database. And let's give this a label as well. So I'm going to call this app layer. Okay, so what is the solution here? So what is the first requirement? Well, firstly, we need to tell our system, hey, it's time to start generating reports. And the best way to do that is to set up a cron job. So let's say over here that we have a cron. And our cron is going to run at, let's say, midnight.
Hey, so we're basically
So what
on the
could we
same
use
path.
for this cron? Well, there's several different options. We could use, say, a Kubernetes cron. We could also use a HTTP request and use an external service that's going to send that. We could even just set up a cron file on the server, but that's not going to work because we're horizontally scaling here. So let's determine what we're going to use a little bit later. So when our cron hits our application, let's write some notes here of what it's going to do. So 1, the cron is going to hit the app. And then what happens when our cron job hits the app? Well, it needs to determine what reports to run. So it's going to determine reports to run. Okay, so now we're up to this step here. So what happens when we have all these reports that we know need to be run? So we have all these reports.
Off the bat, I mean, it's pretty much the same, right? He deferred figuring out what implementation would do the cron job, but he's talking about doing a cron job to trigger daily, and then a way to figure out the list of reports. So I think we're basically on the same path.
Reports that we know we need to run now. How are we going to distribute that load across all of our services running on the application layer? For this, I'm going to use a queue. And when I say a queue, I don't mean just a queue data structure. I mean a service like AWS SQS.
Yeah, buddy. So we're basically on the same path, right? I have SQSQ. I think the one takeaway from this video is SQS is like one of the coolest services you can use. I mean, you could bring like RabbitMQ or ActiveMQ for like a message broker, but SQS is one of the most powerful things that you can use in AWS to kind of glue stuff together. You got to learn it, right? If you don't know it, go learn it. It's amazing.
And the queue is going to have 2 jobs. Firstly, it needs to produce messages. And then secondly, it needs to consume and delete messages. So once we've determined what reports we're going to run, we're going to create a message on the queue for each report. Okay, so now we've created a message on the queue for each report. We now need to start consuming those messages back off the queue. So let's diagram that here. So let's say I'm using SQS. Now I'm going to start consuming those messages off SQS. And because I'm using SQS, I may as well use that as my cron service as well. So let's say we're using SQS as our cron. So I'm going to have a couple of different queues here. One I'm going to have for our cron, and then the second one is going to be for our reports that we need to run. Okay, so we've created a message on the queue for each report. Now what do we need to do?
I'm not sure about the cron thing with SQS. Maybe he'll explain it in a bit, but
we need to start consuming the messages. And when we consume a message, we're going to run the report. So we're going to generate report. And when we're finished generating the report, we need to delete the message off the queue.
the one thing I'll say about when you use like SQS and Lambda in combination, the consuming the message and deleting the message are basically given to you automatically, right? There's behind the scenes, Lambda basically will delete the message automatically when you're done processing the event and your Lambda doesn't throw errors. So he's using a more like Docker approach with probably Kubernetes, I think he said. So he has to manually probably use the SDK to consume messages and then delete those messages. Just a little bit of extra overhead, but it's nice pointing that out, I guess.
Okay, so what if we run into this scenario here where we're 10 seconds into generating this report that is actually going to take 90 seconds? So what's going to happen is we're going to say disconnect from our queue. So let's make another list. This is going to be gets kill signal. What we're going to do is we're going to disconnect from SQS. So we're going to say to SQS, hey, this instance of the application, so let's say it's this one here that's got the kill signal. This instance can no longer receive any more messages. If we have a query running to our database, we can terminate that query. And then finally, we can shut down the service.
That's something I didn't really cover in my diagram, is like if you're currently trying to save the report to SQS, or sorry, save the report to the bucket, or maybe there's some type of database that you need to like send the report to. I didn't consider like killing that. But due to race conditions, like handling that stuff in implementation, it's very hard, right? Sometimes you just have to let stuff flow through and then you have to go back and figure out, okay, well, I actually need to go back and delete that. So one thing I probably should have thought about is when you do the kill switch, figure out what has already been stored in the bucket and remove any stored processes. Okay, now how do you figure out which ones have finished or not? Well, you probably need to use a database and keep track every time this thing finishes something, or you could probably tag things in the S3 bucket, but maybe you have like a metadata table. Like this is a DynamoDB table, and as it's finishing processing things, you have to keep track of what finished. So I kind of missed a couple of things, but like I said, you don't think of all the edge cases while you're designing. You really have to get into the details of things and start implementing, and then you realize, oh, I forgot something really major here. So those are some things that I think I missed, and it's cool that he's pointing them out.
So we've got to this step here, we've got to step 5, but we haven't got to step 6. Because we've shut down the service and we've disconnected from SQS. And so what's going to happen is SQS is going to say, hey, you had 15 minutes to consume this message off the queue. You didn't consume it. I'm going to try this again. And then on the queue, we should set a retry limit. So let's say the retry limit is 5. And then after 5 attempts, if the message doesn't get received, it's going to go onto the dead letter queue. And then when a message ends up on the dead letter queue, we're going to get notified. And that means that there's something wrong with our system that we need to go fix. So this is how I would solve this interview question. If you have a different answer, let me know in the comments section.
Yeah, so this is a pretty cool exercise. The one thing I'm kind of confused about is the kill switch. Like how, maybe this is like a Kubernetes Docker thing. If you have like, let's say 100 of these things running in parallel already or concurrently already, and you just like send a kill signal to all of them, maybe it's super easy. I don't know how you do this in Kubernetes, but something has to kill them, right? So I don't know if that's like an external service or a user. And if it's a simple like kubectl kill and you kill all the pods that are running, I don't know. He seems like he knows a lot more about Kubernetes than me. So I'm just going to assume he has this kind of designed out pretty good. But yeah, I mean, he mentioned a lot of things that are very similar to what I did. But I think we're kind of like overlapping in some of the same areas of like, how would we solve this problem, which is good. I think whenever you need to solve harder problems in software and like design systems, it's good to have multiple people in a room all trying to build systems together to figure out, hey, like, are there edge cases that we're missing here? So this is by far like one of the coolest videos I think I've done on this channel. I really love this like system level diagramming type of stuff. And the fact that he, was able to have his own solution, I kind of shared my solution. And hopefully as you, the viewer, maybe you learned something new. Maybe you learned 10 new things watching this video. I hope you guys did. But like always, I have a Discord channel. You guys are welcome to join. Be sure to hang out there if you want to ask questions about coding or just, find a place to get help or just find mentorship. We got a lot of good experienced developers there if you need to ask questions. And lastly, before I leave, Make sure you go check out Tom Does Tech. He has a lot of good videos. If you ever wanted to learn more about like Next.js, go check him out. He has a lot of stuff. Other than that, have a good day. Happy coding.